Lesson 7.4, we are looking at specific types of parallelograms. So what are some properties of special parallelograms? Not just any old parallelogram, but certain kinds. Before we get started, I would like you to find the 6 missing angle measures in these two diagrams. So pause the video and we'll check back in. All right, so that first diagram, I actually did number 2 first because I know that those are alternate interior angles. Therefore, that would be 39 degrees as well. And then they have to be 90-degree angles because it's a quadrilateral and it's a parallelogram. And we know that this angle is 90, so that's got to be 90, which allowed me to figure out that angle 1 was 41. Now, again, because it's a parallelogram, that 90-degree angle is across from angle 3, which is why it too is a right angle. Now, this next one was a little trickier in my opinion, made you think a little bit. First I did angle 6 was also 22 degrees. They're alternate interior angles, got that, no problem. But the next part you had to think about. Since it's a parallelogram, these angles would add up to 180 degrees. Well, 180 minus 125 means that this little angle here has to be 55 degrees. Well, I've already used up 22 of it, so 55 minus 22 is where I'm getting that 33 degrees for angle 4, which it's opposite, alternate interior of angle 5, therefore it too is 33 degrees. Okay, we're going to keep reviewing a little bit. I want you to just think about these. Are they always, sometimes, or never true? So pause the video and then we're going to go through and talk about it. Number 7, an isosceles triangle is a right triangle. That's not always true because there's an isosceles triangle. These two sides are congruent. Whoops. But it's clearly not a right triangle. But it can be true. If I have a 45, 45, 90 triangle, then those sides would be congruent. So sometimes it's true, but not always. Number 8, a right triangle is a scalene triangle. Scalene means it has 3 different side lengths. Sometimes that's true, right? Because we just showed it doesn't always have to be true. That one's isosceles. So there's the case, sure, where we have 3 different side lengths for a right triangle. But it doesn't always necessarily have to be true. Number 9, an equilateral triangle is an equal angular triangle. Think about it. If all of the sides are equal, what does that mean? All angles have to be equal. So this one is always true. Last one, a right triangle is an equilateral triangle. Right triangle means it's got a 90-degree angle. Equilateral triangle, we just said, means all angles are equal, therefore all angles are 60. So if all angles are 60, can one of them be right? Nope. So this would be a case where it's never true. All right, now, no laughing. Might feel like we're going way back to kindergarten, but we got to talk about it. A rhombus is a parallelogram with 4 congruent sides. All of the sides are equal. We know nothing about the angles. That's it. A rectangle is a parallelogram with 4 right or 4 congruent angles. So we know that the opposite sides are congruent because it's a parallelogram, right? But we just know that the angles are 90. Now this is what I always say in class. It is like these 2 shapes had a baby and made a square. Because a square is a combination of both. A square is a rhombus, because all the sides are congruent, and a square is also a rectangle, because all of the angles are congruent. They're all 90. If you do not know the definitions of these shapes, I highly, highly recommend that you write these down on your note card or a piece of paper where you can access them easily. These are our definitions. Now, these corollaries basically say the same exact thing. It's just saying it's a rhombus if and only if it has 4 congruent sides. It's a rectangle if and only if it has 4 right angles or 4 congruent angles. It's a square if and only if it's both of those things together, right? So those corollaries are really just the definition, but that's what we would use if we were going to write a proof. Now, I'm going to make you think just a little bit more. You have to decide if this is always or sometimes true. Never is not even an option. Decide, draw a diagram, whether this is true. So pause the video, go ahead, draw your diagram. All right, so I don't have the best diagrams, but for letter A, is the angle Q always congruent to the angle S? Well, they're opposite of each other, And since it's a rhombus, that means it's a parallelogram. What do we know about parallelograms? Opposite angles are congruent. So that's always true. Now this next one, notice how Q and R are next to each other in our drawing. When is the only case, think about it, that a rhombus would have these two angles in a row, be congruent to one another? It is the only case when it is a square. So I'm going to write that down. It's sometimes true when it's a square because both of those would have to be 90 degrees. All right, and number 2, it says classify this quadrilateral. So it's quadrilateral, check. Opposite sides are congruent, check. Therefore, it's a parallelogram, right? Now, we have to keep going, see if there's anything else. Rectangles out, because they're not 90-degree angles, therefore squares out. But since all 4 sides are congruent, it is also a rhombus. Those are the 2 names that I could give it. Rhombus is more specific, but both of those names would work. Alrighty, here's some more. Always, sometimes, or never. Decide if these are true, and I would recommend drawing a diagram when you can. Alrighty, number 3. I bet I got some of you on that one. JK is the top segment here. Yours might have been your left and right, doesn't matter. LM is the bottom. These 2 segments are not next to each other, so they can't be perpendicular. In fact, those 2 segments are parallel to one another. So it is never, they're never perpendicular. Number 4, if it's a rectangle, and we're looking at side FG, again, yours could have been in a different position on the rectangle, that's fine, and GH. The only time that these 2 would be congruent is if this rectangle was also a square. Special case. And then last one, it says draw a quadrilateral with 4 congruent sides and 4 congruent angles. That makes it a square by the square corollary, or the definition of a square. We are going to go ahead and pause here for today, and we'll finish lesson 7.4 in the next video.